Good afternoon, Professor. This is my fifth assignment of Electroceuticals. The topic of this assignment is uh, deep brain simulation for Parkinson's disease. Abstract of this paper was uh, DBS therapy is the DBS stands for deep brain simulation. Is this therapy is considered one of the most important advanced treatment of Parkinson's disease or progressive neuro degenerative disorders, and it improves cardinal motor symptoms of the Parkinson's disease, and marked reduced to motor complications, uh, and dramatically improve quality of life. The author revealed the working of the principle of DBS in the term of past and present science era, and has also explained the clinical indications and up-to-date evidence on clinical outcomes of DBS, along with the risk and side effect and advance in DBS technology are discussed. And these are the component of DBS systems, and in this figure also clearly explain DBS leads it. This insulate the coiled and wires which ending in a tiny enclosure that delivers simulation to target area, and this is the extension area which is wired and insulated that connect the lead to the neurostimulator, and this is the neurostimulator which is connected with every green and purple line which is connected to the brain also. A pacemaker like device that contains a battery and circuitry to generate electrical signals that are delivered by leads to target structure deep within the brain, uh, and the and the clinical can program and adjust the setting of the neurostimulator extremely via hand held device. Now this slide is about the overview of deep brain simulations. To treat Parkinson's disease, medical therapy includes placing electrodes or conductor in the brain which sends electric impulse that changes the unusual signals. The contact, which the tips of electron has four metal rings at the end of it called as a contact, and the stimulator is turned on. Electrical impulse travel from pulse generator through extension wire and the out of the contact. The resulting critical stimulation of the brain can improve the symptoms of many medical conditions. This approach consists of four parts: leads, pacemaker like device, and delay that transmit electric pulse, and handhelder computer operate that adjust the device sign. And next is quadrupolar electrodes leads used to deep brain simulation. Each contact of electrode in 1.5 mm long and 1.227 mm in diameter, and the left model the 3387 in which the contacts are pace 1.5 mm part. Right model 3389 in which the contacts are paced 0.5 mm part. History is in 1890s. The Victory Hollis was a pioneer in regret and perform cortical motor split resection to address uh, tumor, And this slide is about all the revolution of DBS, and I am going to uh, explain a few lines about this. Is like in 1980s, surgical therapies of PD has happened, and because of that, lipodine therapy was associated with deliberating on of motor fluctuation and asking at the disease. And in 92, Leston reports of Paladin as an effective surgical treatment of PD lead to increased interest in targeted. And with the high frequency STN simulation has been found to effective for the cardinal motor system of PD improve the quality of life. Now, how does this work? The DBS work. In this a pre-operative evaluation is performed the prior procedure is a pre-operative evaluation is performed in order to maximize the success of DBS surgery. Evaluation may include brain MRI scan, neurophysical logic testing, videotaped evaluation of movement both on and off medication and other if indicated. Precious placement of electrodes is achieved both by MRI measurement as well as intraoperative electrode mapping. Once the electrode are placed, the wire is connected to the neurostimulator power supply. Then the system offer the often brain pacemaker and regulate the abnormal signals resulting from the disease process, and the electrode impulse generate the securely placed. The electrodes send the electric impulse that help normalize normal impulses. This figure I have got from this link. And this slide is about DBS for Parkinson clinical outcomes. There are two main DBS target for PD: substactical nucleus and global pedalians in turn. In both improve the cardiac system as well as motor functions, and it also target VMI, Tamulus and pediculopotian nucleus, and VIM target reduce Parkinson terminal, and PPN simulation is investigated for joint problem and freezing in PD, and it offers constantly great dominic medication reduce possible middle benefit in non-motored domain and uh, simulation. It also provide advantage of Dickinson suspension management of symptoms with unalterable leads and flexibility in medication and programming adjustment. And conclusion is about similar consistent marked motor benefit but still target difference exist. This is the comparison table of GPI and STN, and this slide is about surgical risk and side effect of simulation. In this complications include those associated with neurosurgical procedures such as subdural and CF leak, pulmonary embolism, pneumonia, and bleeding, wound infection, postvious, and pre-operative confusions. In addition, DBS process are associated with with a similarity of 3% chance of intercerebral hemorrhage, and patients with hypertension are high risk of this disease, and the Risk also increase with the number of electrode paths needed. Hardware-related complex has been stimulated over 5 to 9 patients, and such complication may infection, device malfunctions such as electrode wire break and impairment pulse generated, and malfunction skin erosions. And the effect of this stimulation related is they affect with surgical target and can be minimized with reprogramming. And it has VIM simulation include the hysteria, panesthesis, the dystonia, postal instability, extonia, and limb weakness. And other side effect is like peglitin simulation may include blurry visions and light flashes, the hysteria and paresthesis or motor construction. And it has a common side effect like the hysteria, paresthesis, motor construction, dipolian, uh, light head, sweating, and dexinias or